tool for the prom tent that we're putting up. Because we're putting a giant tent in the middle school gym, so it doesn't look so much like a gym. That looks more like a prom. So yeah, because I'm a prom queen this year.
It didn't look that bad. I thought they did a pretty good job making it not look like a gym. I thought that too.
Yeah, All right, here we go. This triangle. What's the largest area this triangle could be? Okay. Now, because, I mean, we could make the triangle skinnier like this, or we could make it really short and fat like this. We're just wondering, where do we put it to make it the largest possible area, to maximize the area? So, what is the area formula for a triangle? 1/2 the base times the height. Okay, on this triangle, what's the length of the base? From here to here, what's the length of the base? Trey. It's not a number. Not just x, because x goes from here to here. 2x. Woo! All right. 2x is the length of the base. What's the height of this? The f of x. There you go. See the y value, which is the f of x. Hey, it says the f of x right here is 9 minus x squared. Okay. So how many variables do I have? Just one. Well, I don't have x's and y's and z's and p's and q's. I have just x's. One variable. Okay? Now, let's simplify this. Yep, I am recording this. Well, let's simplify this. How do we simplify this? X times 9 minus x squared, or 9x minus x cubed, correct? So that's the formula for the area of that triangle. Now, to find the maximum area, take the first derivative. What's first derivative of that? 9 minus 3x squared. Set it equal to 0. Move the 3x squared over. Divide by 3. X equals what? Square root of 3. Now we're going to plug it back in. Okay? If we plug it back in, the area is going to be 1/2, 2 times the square root of 3 times 9 minus the square root of 3 squared. So half of 2, we just get square root of 3. Square root of 3 squared is 3. 9 minus 3 is 6. So it's 6 squared root of 3 is the maximum possible area of that triangle. That's optimization. Okay. F of x is defined as that function. What is the x coordinate of the point that is closest to the origin? When I talk about closest to the origin, what am I talking about? Closest to 0, 0, so what do I have to use? What type of thing do I use? No, I'm not going to graph it. No. How do you figure out how far it is from here to there? Distance formula. Slope, really? Come on. It's a distance formula. So I have to find the distance. Now this is what f of x is. So the point is going to be x f of x. Right? That's my point. It's going to be some x value, and whatever x value I put into there, that's going to give me the y value for my xy. What's the other point involved in this problem? 0, 0, the origin. Now I have to find the distance between those 2 points. X minus 0 squared plus 2x minus 3 minus 0 squared, which is x squared plus 2x minus 3 squared. How do we do 2x minus 3 squared? Foil it. 2x times 2x is 4x squared. Outers is negative 6x. Inners is negative 6x, which is negative 12x plus 9. So it is the square root of 5x squared minus 12x plus 9. Now we're going to do what to that? What? What are we going to do to that? What? This is an optimization problem. Derivative. To find the closest to the origin is the minimum. Take the first derivative to find the minimum. How do you take the first derivative of that? Well, you do 1/2 times 5x squared minus 12, that's squared, minus 12x plus 9 to the negative 1/2 times 10x minus 12. So what am I going to get? Well, I'm going to get 10x minus 12 over 2 square root of 5x squared minus 12x plus 9 equals 0. Well, if I set it equal to 0, does the denominator even matter? No, it's the numerator. 10x minus 12 equals 0. 10x equals 12. Divide by 10. X equals 6/5. So at the point 6/5, I'm going to be the closest to the origin out of any point there is. Okay, optimization. Now, let's not have a straight line. Let's have a parabola. Which point on that parabola is going to be closest to the origin? Distance formula. My 2 points are x squared minus 1, and 0, 0. So it's the distance of the square root of x minus 0 squared plus x squared minus 1 minus 0 squared. So it's x squared plus x squared minus 1 squared, which is x squared plus FOIL. What's x squared times x squared? X to the fourth. Outers is negative x squared. Inners is negative x squared. So it's negative 2x squared plus 1. What's x squared minus 2x squared? So it's x to the fourth minus x squared plus 1 is what's in the quantity. Now we're going to take the first derivative of that, right? Which is basically this on the bottom with a 2 on the bottom, right? What's the first derivative of the inside? That goes on top. 4x cubed minus 2x. So we set 4x cubed minus 2x equals 0, and then we solve. What can we take out? 2x. And we get x squared. So it's x squared minus 1. 2x squared minus 1. So x equals 0, or 2x squared equals 1. So x squared equals 1/2. So if we take the square root, x equals negative, well, let's not go there, Mr. Bierschbach, yet. The square root of 1/2 is the square root of 1, which is 1 over the square root of 2. Can't leave square root of 2 on the bottom. So x equals plus or minus square root of 2 over 2. Or else 0. So it's 0, negative 1, or square root of 2 over 2. What's the biggest perimeter I can have on that rectangle? Well, how do you find the perimeter of, well, here's a rectangle. This point is x f of x. What's the length of the base of the rectangle? 2x, because there's x here and x here. What's the height of it? F of x, which is 4 minus x squared. How do you find the perimeter? Perimeter is 2 times the base plus 2 times the height, right? So if we want to maximize the perimeter, it's 2 times 2x plus 2 times 4 minus x squared. Okay? So the perimeter is 4x plus 8 minus 2x squared, correct? So what's the first derivative of the perimeter? So it equals 0. What is x going to equal? X will equal 1. So then what do we, then we have to plug it back into the perimeter formula. So you get 4 plus 8 minus 2, which is perimeter of 10. Okay? You can handle that, right? Positive numbers. X and a minus x have a sum of a. What product would be their maximum? So you take x times a minus x, which is ax minus x squared, right? And you want that to be a maximum. So what do? If you want to find a maximum, what do? First derivative. What's the first derivative of this? A is a number. A minus 2x. Set it equal to 0. They're wondering what x would be in terms of a. So, divided by 2. All right. A divided by 2 is x. Choice A. Last one. Trig one. What argument for x is the maximum vertical distance between these two curves? Ooh. Distance between those two curves is the distance formula. 2 cosine of x squared plus sine of 2x squared, right? Ooh, this ain't very friendly. What is another format for the sine of 2x? It's 2 sine of x cosine of x, right? Wait, actually, if we're just going maximum vertical distance, I think I can just subtract those two from each other because they're two y values. So just take 2 cosine of x minus sine of 2x, which is 2 cosine of x minus 2 sine of x cosine of x. There we go. Now we have to take the first derivative of that bad boy. What's the first derivative of 2 cosine of x? Negative 2 sine of x. Minus, what's the first derivative of this? Well, that would be the product rule. 2 sine of x times negative sine of x plus 2 cosine of x times cosine of x. So it's negative 2 sine of x plus 2 sine squared of x, because minus a negative is plus positive, minus 2 cosine squared of x. But what do we want? We want them all to be the same. Distributed this minus sign in front of the parentheses, through the parentheses. Because this minus sign was here. If I multiply this minus sign times this one, it becomes a plus. Multiply this minus sign times this plus, it becomes a minus. Okay, so we need them all to be the same trig function. Can I change sine squared into cosine squared? Yeah. Can I change cosine squared into sine squared? Yeah. What is cosine squared the same as? Pythagorean identity. 1 minus sine squared of x. So if we distribute that 2 through there, I get 4 sine squared of x minus 2 sine of x minus 2. So if I factor out a 2, I get 2 sine squared of x minus sine of x minus 1. How does that factor? Two sine of x and sine of x. What makes plus 1 minus 1? Because you get negative, and then plus makes a negative, equals 0. So 2 sine of x plus 1 equals 0. Sine of x minus 1 equals 0. So 2 sine of x equals negative 1. So sine of x equals negative 1/2. And sine of x equals 1. Where is the sine of x equal to 1 at? No? At pi over 2. At pi over 2, it's equal to 1. Where is the sine of x equal to negative 1/2? Negative pi over 6, and then 7 pi over 6. Now they say in between these two, well, pi over 2 is not in between those two. And 7 pi over 6 isn't in between those two. So it'd be negative pi over 6. Optimization problems. Oofda. Just wait till the AP test. There's some fun ones on there, I'm sure. All right, so there you go. That's what you have for today. You only have 4 problems, but you have a bunch of videos. Go.